repositories here, my part will mostly be in Markdown, so you will not be using notebook file at the beginning. After, we will use a notebook with John, but I felt that using notebook for modifying the notebook interface was not really well suited. So yeah, you can read through the first one if you want to have some introduction. You can basically do the whole tutorial offline if you want without me speaking, but I will try to guide you through that. So one nice thing is once you have finished this tutorial, you will probably be in the world 50 people that know how to do these kind of things, so you can consider yourself experts. So feel free to ask and be happy about that. So I will mostly be using Chrome. You can use Firefox, it's okay. I'm not sure exactly how to use a shortcut in Firefox and exactly where are the things in the menu. Thomas might be able to help you with that. I don't know if you can do any of these things with Internet Explorer. We don't really support Internet Explorer, so I hope none of you have Internet Explorer. Otherwise, you will probably be on your own. And so what we will do now is try to understand how you can fiddle with things, with web pages in your web browser and know some advanced tools that not everybody knows about. In Chrome, you can go to View Developers Tools. I need to zoom in. So if I go to View Developer, and you have basically the three things here do the same. And what we want is developer tools. It will open this, which I have a lot of errors, but it's fine. You often have errors on the web. We can also do the same on a notebook page. So let me start a notebook on the directory of the tutorials. I can go to part 1, and I have one notebook we might be using, but there is not many things in it. And you can see here that we have the developer tools. And basically, the developer tools will allow you to modify the web page. Let me just remove one thing from my profile. I went too far in the tutorial already. Here. So you should get an error. You won't get this error. And, so basically, now that we have these developer tools, you have many panels that can help you to mess with a web page. The first one we'll see is element here. So basically, when you move your mouse around here, you will have the tree representation that show you the structure of the web page. And so you can, for example, try to find an object. Like I will try to drill into that. Go here into the main toolbar. There is a menu here. They can expand, and basically you can see the structure and you can change it live. So I will try to find something like the kernel indicator. Here it's a Python tree. I can double click and say hi SciPy, and it's changed on the page. So basically, you will need that if you want to mess around with HTML, understand how it works, and understand how to manipulate all the notebook UI and make extensions. On the side here, I hope it's bigger on your screen. You have the things to mess with the CSS, which deal with the presentation of the page. Things that can be useful is to create a new things and say, for example, cell border. Thick, solid, red. I probably need to know a bit of CSS, and well, now all my cells have a red border, and it will help me to understand what is the structure of the page and where are our things. And the last piece we will use is the JavaScript console, which is here, where basically you can live interact with the JavaScript context which is on the page. And we have, for you, we have injected a few things like on IPython 2 and 3, you can access IPython global. And the IPython global has lots of what is uppercase are modules or classes if you want to do the parallel with Python. You can basically mess around with all the code which is running in the page. Not the code which is in your kernel, in your Python kernel, or in your Haskell kernel, but all the code that will drive the application in the page. And basically, that's the thing you want to mess with to change how the notebook behave and how you can get custom shortcuts or buttons that will, I don't know, make things rotate or lint the code or change the highlighting and things like that. That's basically how we have all these buttons and this menu already that are extensible. So if you want to show and hide this developer tool that you will use a lot. On Mac and Chrome, it's Command, Option, or Apple Alt. The name keep changing after the years, and I, and it will just toggle it in and on and off. And one thing you want to do as soon as possible is to go to this setting on the side here and check these things, disable cache while DevTool is open. Another possibility is to download a Chrome extension or a Firefox extension that clears the cache, because otherwise, when you will be editing file on disk and reloading the page, even if you reload the page, the browser caching is pretty aggressive, and you might think that you have a new version, but you don't have. And checking that helps. I don't say that it fixes it. So sometimes you have to really aggressively refresh your page to get the new code you will be writing on the page. That's one of the issues you might have with web development. But most of the time, it goes okay. So okay, let's zoom a bit. So here are the different panels you can have in the dev tools. So the DOM tree, the CSS inspector, and the JavaScript console. So you can try these things. If you want to print in JavaScript, usually you use console log and something. Oops, this is the wrong one. If I go into my console here and do console log, hey, hello there, and we get hello there in the console. It gets used to. You have to get used to use console log instead of print. And because of the nature of JavaScript, you have a lot of. You probably heard about callback hell and everything. Everything is asynchronous. So basically, you can do something like that, and basically it should print hi there every 3 seconds. And while it's there, I can still do stuff, and every 3 seconds it will still print something. So you can get things that are running in the background. And usually, because you're in the web page, everything is sandboxed. If you have done something wrong and you're lost and everything, you just refresh the page, and now you're clean to your first environment. Everything you want to do that will persist, you have to do on disk with a text editor somewhere else. So it's a nice sandbox. You cannot break anything. You can play around, change the color, change the shape. So yeah, here it's caching and everything. So now we can go to the fun part, which is learning a bit about JavaScript. You will see that working with JavaScript can be really great sometimes. We are all Python programmer, and we love JavaScript so much. You probably saw Min tweets on Twitter that he loves JavaScript every week of his life. One of the big challenge when you start JavaScript is there is many things that you cannot Google because of their name, because they don't actually really have names. So I will try to introduce them. So you will find on many JavaScript page of scripts the $, and it's really tough to Google that. And you have to know that the $, is basically just an alias for a library called jQuery. And jQuery does really, really a lot of stuff. And yes, if you want to, it's something that acts both as a namespace and a method you can call, and many things. And so if you see the $, and you're wondering why $.css, what it does, you need to Google for jQuery. So the kind of things that this can do, for example, is if I go back to my page here and I ask jQuery to, this is kind of CSS-like syntax. We won't dive into it, but it's just to give you an idea of the things it can do. It will select all the elements of the page that have the class name cell that are odd and remove them from the page. So it's just the visual appearance of the page, right? It's not actually changing the document structure, so it won't remove the cells from the notebook. So if I do that, I will just like remove everything. And I can reload. And you can do other things like the same, but instead of remove, I can slide up. Slide up, I don't remember if it's slide. And I don't know if you saw that, it was just collapsing. I can just ask it to do it slowly. And you see that it goes slowly. I can do even slower. I can say 3 seconds, and it will slowly collapse in 3 seconds. And it's, of course, just change the appearance of the page. But, of course, if you Google for the dollar, Google will not understand. It will understand that you want to convert dollar to euros or whatever. Another library you will use with John especially is underscore. It's relatively difficult to Google for underscore because when you Google for underscore, Google tries to understand that you actually are Googling for the underscore sign. And underscore is mapped to the underscore variable because underscore is also a valid identifier in JavaScript. It's the same. It provides some utilities functions. Most of the time, it helps with some templating and everything. You might also see some weird snippet like var that equals this in JavaScript. And what is this? What is that? This is the equivalent of self. If you come from a Python background. But because of the way the scope is working on JavaScript, when you create a function, when you're in a function in the method of a class, for example, difficult because naming is not exactly the same for JavaScript, this will refer to the current function and not the object. So when you do a closure, for example, like here, I will zoom a bit. You can, for example, in IPython, we have something that roughly looks like that. When you want the current kernel to execute code, you will call it this way. Probably not, should not use this way when you have this in the code. And if you want to delay it, you can write a closure like that, for example, and say, I will do the execution, and I want to do it after a certain delay, for example, 3 seconds. But here, in this circumstance, you would like this to refer to the cell object. But in here, because of JavaScript, this will refer actually to the doX function. So what you will do is just above the doX here to do var that equals this and do that kernel execute. It seems a bit weird. You can find it in some place, and it's usually things that are confusing for people. Another way to do it is, again, with jQuery. The dollar, I remind you, is to use a proxy function, where basically the proxy function will take a function and set this correctly as what you want to do. So you will find $proxy, and you will also find something similar, which is .bind. So we are almost at the end of just talking, and after we can get your end on actually doing some code and some extension for Notebook. So JavaScript does not have actually import like Python have, at least in browser. If you want to do things in some ways, you have to use a complex definition, which look like that. So you will find define, or sometimes instead of define, you will see require. And basically, the way you will use it is to write the name of the module you want here, the different module here, and then pass a function with the parameters which correspond to the above module. It's kind of difficult to get your head around that. And then write your module definition inside. So why it's like that? It's because JavaScript. And it kind of you have to get used to that. There are some good reasons why it's like that. It might be hard to read, but if you trust regular expression and you know how to debug things with regular expression, you can use this syntax, which is slightly better that don't work in all the case, where you say var the name of my module equal require the something else I want to import, which is equivalent to import base.js.namespace as namespace that you would do in Python. And roughly, you will see that in many places. And now the last thing, one of the two last things we'll do is, to be safe, you want to put a string like that at the top of your module definition. It will basically help JavaScript to behave in a normal way that you expect it to behave, like not attach things to global when you implicitly forget to put a var in front of a variable you declare. And so basically your module that you will write will start with define the list of strings that declares the module you want to import, a function that retakes a different name of the things you want to import, and then you strict, and then after you write your module. It's a bit painful, but that's how JavaScript. Yeah, now from gotcha. JavaScript will never complain if you don't give enough or too much argument to a function. It will just drop the argument that you can still get in some weird way if you want, or set them to undefined. Equal is not equal, because equal will cast things to try to do the smart things for you yeah, whatever. I don't know exactly why. But the string 0 is equal to 0, is equal to 0. 0 is equal to empty string, and empty string is not equal, whatever. Use triple equal when you can. And the last thing you might see that you shouldn't be worried about and try to just forget, it's things that look super weird when a variable is equal to a function in between parentheses that take another variable or even sometimes the same variable and which is called with itself in the end. That's because JavaScript has scope problem, and basically this is just creating a scope which is equivalent to doing curly bracket in C. So this is equivalent to curly bracket in C. Yeah, so roughly, if you don't do that, in some case, it would behave as if Python would do that. And you don't want that. So sometimes you will just, it's fake. It's basically just to make you understand how it works. Basically, you want to create a function immediately and call it with a variable of your loop. And you might see that in some places. You don't have to worry. It's just as often JavaScript. Yeah, so I explain. And the last thing is Mozilla Developer Network is your best friend. It has a really good documentation. So when you want to Google something, Google it and add MDN at the end, and we will most of the time get a nice page with even translation for those of a few of you that are French and that prefer reading documentation in French or in Russian or I don't know. With that, you should basically had a 20-minute crash course on how to write JavaScript. And now I guess you start to understand why we love JavaScript. Okay, so let's actually do some coding now. Okay, notebook extensions. There are many things that can be notebook extensions. I wrote one which is called Jupyter Drive, which allow you to get your notebooks directly from Google. You can have extensions that allow you to insert citations by writing the BibTeX references. You can have extensions that allow you to select multiple cells or that change the color of the notebook and everything. You have a few repos that I know of that have extensions. You have an IPython contrib on GitHub organizations where Damien Avila and Jürgen Harsch are writing a lot of extensions that are really nice, like to put breakpoint on the side of cells or everything like that. And there is pretty long documentation on how to install extensions. It's roughly, the extensions are not always super well maintained, and some of them you need to actually modify the code for them and send pull request. But basically, what we will do is create a minimal extension and see how to load it. You will see it's really simple. To do that, you have to create a JavaScript file. I haven't created it for you in the repository, and put it in this location for you, so in .ipython nb extension. And I created one which is hello SciPy. So let's see here. Let's go back to SciPy Advanced Tutorial, Part 1. CD extensions. I will get something with syntax highlighting, it will be better. And now you should have one file which is called hello.scipy.js. SciPy.js. Oh, sorry, I need to increase the font size. You can remind me when I don't do that. So basically, let's do that. Let's edit it to see what it looks like. Hello SciPy.js with a dot. And we'll forget about these 3 lines for now. It's relatively simple. Oh, sorry, I need to, yes, the font. So the defined, I'm using the simple syntax because I don't require any modules. I create a function here that will basically return my module. And I create a function that on load will just say console info, hello SciPy. And load IPython extension, basically I export this function with the name load IPython extension. So now what I want you to do is to drop this file, copy it, link it, depending on how you are comfortable with the shell, into your .ipython/nb extensions that should already exist. And so when it's done, you can go to your notebook. So I've created one for you also in the repository if you want to. And take the small line which is here in the tutorial, notes that don't really worry about what it does right now. Basically, it will just say, hey, load these extensions named hello SciPy. The name here should match the name of the file without the .js. And so I will go there. I will pass this there, and there is no error, so the extensions should be loaded right now. I haven't copied it yet, so I will cp. You can try to do that at the same time. Hello JS into .ipython nb extension, and I reload, and I see hello SciPy 2015. So I will give you 3-4 minutes to try to do that on your own. And if you do that correctly, I will have a way to know that. So go ahead, try to get the extension loading, and after we will modify this file for the rest of the tutorial to build an extension. You're not obliged to delete the 3 lines of garbage here. Basically, I will continue. If the 3 lines of garbage should show you something, because they're not garbage. Yeah. So basically, it should show you. If you read that in your browser console, you can now say out loud, "I am a JavaScript expert." And so this way, I can know that everyone has an extension installed. So does someone have the extension not working? You can raise your hand. I won't bite you. And if it doesn't work now, you will get stuck for the rest of the tutorial. Or you might get stuck. You have a problem. The room is full of experts. One of the requests we have is, hey, can I have a keyboard shortcut for something? I want Shift-K to move the cell up, Shift-J to move the cell down, or 000 to restart the kernel, clear all cells, and rerun all without asking confirmations. Because we are in a web environment, the number of shortcuts we have and that we can intercept is really small. So that's why the number of shortcuts that are by default in IPython is extremely limited. But it's pretty easy to add your own in an extension. So what you want to do is change the first line of our extensions to require base.js namespace and have the functions that import this module to expose it as IPython. So you can modify hello SciPy.js. Now that it's in the right location, as it loads, you can just modify it. You might want to git init nb extension folder and add the file and commit for the first time, just to be sure that you can get back to your previous version when you do some stuff. And the IPython global expose some things that allow you to bind keyboard shortcuts. Basically, we will make a small detour to see how to do that. So you will basically use something like that in your extensions, which will register something you want to do. We will see just after what it is. We want to, for example, remove a shortcut which is already existing. For example, I will later remove 00, because 00 right now in the notebook will kill the kernel and ask you if you want to kill the kernel. Oops, I need to click here. And I want to get rid of this shortcut because I want 000 to restart without asking and clear all cells. So, to do that, we need to define something which is more global than just an action, because we want to, most of the time, reuse the same actions that we want to do in many places, in particular in menus and toolbars. So that's why we will define what an action is. So we'll make a small detour here. There is an explanation on how to add shortcut and remove shortcut, which is much longer. And basically, an action is something like that, which is clear all cell and restart. You give it a help, because sometimes you don't remember what exactly it does. You can give it an icon. The name of the icon you can find from a library called Font Awesome. And all these icons, for example, if you use fa-car, you will get this icon when later you have the action. You want to give it an help index, which is optional if you want to sort it in the quick help menu. And a property is called handler, which is a function that takes one parameter, and from this parameter you can extract the notebook and ask the notebook to do some things. And so here, for example, this will clear all output and ask the notebook kernel, or actually it's missing a dot restart here. I need to change that. To restart and to do something else on success, and something on success and something on error. So if you define that in your extension, you can do that at the same time. Let me just modify the extension, which is in my dot. So you can do it at the same time. You probably want to have your own action, which is not clear and restart. I will just do this example. So I will remove that because I don't need it anymore. So now I have just defined up here dot restart. And I can even probably try that in a live notebook. I can come here and try Python restart. Oh, you see the kernel is restarting. I haven't passed any on success and on error. It's just in the example to show you how you could do that. And now, instead of showing that here, what I want to do is reuse what is here and adapt it to actually bind 000 to kill the kernel, restart everything without asking me any information. So here I want to register. Oh, set no wrap. Wrapping is confusing for me. So here I want to register this thing. And I want to name it clear and restart. And I'll attach it to the namespace IPython 2015. The namespace is basically so that when you share this extension with someone, you don't conflict with their name, and you can have many actions named the same on different namespace. And now I want to unbind 0, 0, which means press 0, then press 0. I can also use different kind of syntax. So for example, shift 0, 0 would mean press shift 0, release shift and press 0 again. And shift 0 would pressing shift 0, shift 0. I want to do that for unbind. So now 0, 0 should not restart the kernel anymore. And now the keyboard manager, I want now to have 0, 0, 0 to kill the kernel, erase all outputs. Okay, so let's see. Are the demo god with me today? Let's restart. I don't see that the extension is loaded anymore. There is not this this info message, and if I press 0, 0, 0, oh, yeah, it works. I will redo that for you. I run that, so you know that it has been run today. Be sure I'm in command mode. I press 0, 0, 0, and it has been restarted. So as an exercise, now you will try to extend these extensions to not only restart and clear our output, but to run all cells once the output is cleared. For that, there is a hint, there is an onSuccess variable in the demo here. You have onSuccess equal undefined. So you probably want that to be a function that access maybe, I don't know, something like ipython.notebook. Something like that run all cells. I don't remember exactly the name of the function. Something like execute all cells seems like a nice name for a function. And you might want to wait for the kernel to wait 1 second after the kernel has restarted to do that, because otherwise the kernel won't be ready to execute. We won't go to the exactly nice way of doing that, which is to actually wait for the event of kernel ready to execute. So yeah, with the help of that, we will probably move that somewhere around here. And so you might want to rename IPython here to env here. I guess I almost did it. It won't work. You just have to know of one more function, which is called set timeout, which take here a function that does something, and a timeout, let's say 2 seconds before doing something. With those tools, in 5 minutes, I'm sure you can find how to modify the extensions to kill the kernel, restart the kernel, clear all output, and rerun all the cells. This line is almost exactly in the material 4 here. You have our internal names. The only thing is here, this string is the one the shortcut you want to unbind. If you want to unbind the shortcut, you can probably want 098 to restart the kernel, and then it doesn't conflict with 00 anymore. So you might want to skip this part. And here you can use syntax like if you want Control Shift D to restart, you can write CTRL-SHIFT-D, and this will be the shortcuts that restart do your action. Of course, it need not to conflict with something else. We try to detect as much as possible whether this shortcut will conflict with our own shortcut, but sometimes it will just be taken by your OS or Chrome. So for example, if you want to try something to Command M, which is minimize window, it will never fire, and you have no way to know that it has been taken by the browser before. Okay, so anyway, there is the solution here, which is basically kernel restart. The first argument is a function which is on success. I could also have written the function here instead of undefined. And on success, it creates another function that after 1 second execute all cell of the notebook. And you can start to see here why JavaScript is callback hell, because you create a function that calls something which takes an anonymous function, that calls something that takes an anonymous function, and you can go on and so forth, because after you have executed all cells, you might want something to happen here, so you need to have one more function which calls one more function which is super indented, and then you're above your 80 characters limit. And with the solution here. So the question is, why do we want to use an actions with icon and everything and do a lot of coding for basically nothing? Couldn't we just have passed one function to do the thing? It should work. But the last advantage is now that you have all this thing coded, you just need one more line now, which I will pass here and which is in the material. I will speed up a bit because I think I'm late, which takes the internal name here. Oops. Why did I do that? For whatever reason. And here I will pass another name which is internal to IPython just for the example here. And if I now reload my page, I should have these two new buttons here. The one with FA recycle, which is basically here. I will change this to FA car. So now it's a car. Yeah, you see, now it's a car. Why a car? I don't know. So when you click on this button, it will do the same thing. You see, it just restarted the kernel and clear all the cell. And now also, if you go to help and keyboard shortcuts, you have nicely this 0, 0, 0. Clear all cells and restart kernel without confirmations. So we were a little bit verbose here and make something slightly more complicated with a help string, with an icon, with an help index, and a handler. And now for free, we have the ability to create easily a cell toolbar with a button that has the right icon, and which will do exactly the same thing than the keyboard shortcut. So you sure that if you want to change what does a keyboard shortcut, you won't forget to change what the cell toolbar is doing. So these are minimal examples, and I invite you to go see the different link I put up on the materials that show you the kind of extension you can do. There is one annoying thing, and we are working on that. It's documentation. Like right now, if you want to know what a notebook can do, you have to grep through the source file of the JavaScript to know that notebook can execute all cells, or execute only odd cells, or execute cells from this index to this index. We are working on that. We will slowly rewrite JavaScript in TypeScript, which gives you documentation for free, and you will still be able to call things from JavaScript, possibly with minimal change, but it might change a bit. And we will be happy if you write extension like that and find missing documentations and imprecisions that you can and do PRs, so that it's even easier to extend the notebook. Right, I might speed a bit here, I'm sorry. You might want to interact with the user. For that, we have a convenience method, a convenience module, which is called Dialog, which you can find in base.js dialog. And it will just pop up a model dialog, and which take lots of parameters that will just give a user an interface with buttons. Okay, cancel. I don't know. Please help me. Why JavaScript? And after with this dialog, you can get user input or things like that. And so you can do nice small things like that. Where this is an exercise I wanted to do if I had enough time, but we don't have enough time. So here, for example, it's a small extensions where you type a name of an action that you have written before, and I've created a few. And for example, I created a spin, and now I can just do that, and yay, it's spin. It's useless, but it works and it's nice. I just did that just for the tutorial.
Is that in the repository?
This one is probably in the repository, yes. If you go into the repository, you have the full solution, which is SciPy full.js, which starts to grow. It's 120 line. We won't have time to do that, so I will just walk you through what it does. So basically here is what you should just have done now, which is actually doing the restart and executing all cells without asking me for confirmations that I made as separate function. You see here on the top that I'm requiring a few modules like namespace, dialog to pump a dialog, jQuery because I want the dollar thing that I cannot Google. And this is another extension I wrote, which is in a separate file, and that shows you that if you write one extension, you can require this extension from another extension. So you can basically build a library of extensions. And usually the nice things to do is to only have an extension that define a lot of actions you want to do and not actually bind them to shortcuts or not create toolbars, and only do the binding in your own files where you will be doing things where you want your preferences and share this extension on the internet. So I can, for example, create an extension which is do restart without confirmations, ship it on the internet, and you will be responsible for binding it to 000. And so it's basically, you know what packaging is. It's packaging for extensions. You can do that. Only drawback is it's JavaScript. Yeah, but you know that. And here it's basically how to write a dialog which will create with jQuery, create a p tag, which is a paragraph tag with a text. For example, this is another extension that does something. Please enter why you would like to restart the kernel, create a text area, create a div, append everything, you need to do something programmatically. It's not always okay. And here we will see that just after we can write server-side extensions that will create custom handler on the server side. So you can either put data on the server or get data from the server. I remind you that the server can be a different machine from the kernel. Like, for example, the citation extension from Thomas will actually read bibtex file, and from the bibtex file, not bibtex file, Zotero
citation style file.
Yeah, citation style file to get the right citation style and from the server itself. So you don't have to go through the kernel. But here I will show you a small extension that just get a request and log it into the terminal. And here you pop a dialog with the previous thing, the div here that we created here with the text area where we want the user to create a reason and why you restart the kernel. And title to the dialog, one button which is go because user never want to cancel and it's too complicated to write a cancel button. It's just 3 lines more and I'm lazy. And it takes some parameters that you have to pass it for some API reason. You just copy and paste and it works. One thing that I was thinking of doing and never had the time to do it is to actually have this text area be a git commit message where you would actually have a commit button in the toolbar and you click, it asks you for a commit message, you type your commit message, and when you press OK, it will actually commit your file by calling git. And you don't actually have to have that in IPython core to have a way to commit file. You can write it as an extension with server extensions. And then you basically, once you call that, the dialog will show, and when you click on go, it will call on OK, which you define above, and it's again the callback hell, but in the other direction. And here I have my clear all and restart first version that doesn't rerun all the cell. And here I have the full extension with show hello SciPy and everything. And yeah. And the last extension to flip the cell was which one? Grep. Spin. Spin star. Maybe not here. cd dot python. And the extensions. Yeah, it's here. And yeah, I know it's so. It's slightly bigger. But basically, the only thing it does is create an action. And here, I don't name the action. I directly pass it to register. I don't want to put in a help. I don't want an icon. I just want you to do transition for everything for 2.3 seconds. And no, it's this one, rotate Y. For 2 seconds and rotate by 180 degrees. And I use the jQuery syntax to target all the cells elements. And I can just like, let's change that for Y. Let's reload this thing. Let's do again spin, quick dialog spin, and it flips in the other direction. It's not really useful, but it works, and it shows you that you can basically completely change the UI if you want to change the color of the thing, if you want to have something that take all your import from all your cells and move them in the first cell of the notebook. You can write that. It's not, you don't need to change the core of IPython to do that. You just need to learn a bit of JavaScript. Personally, it took me 3 years to learn JavaScript. Yes?
Everything that you've shown there with the notebook, the dialogue, the callback is all done on the JavaScript side. There's nothing more back to the kernel.
No, for now, there is nothing in the kernel. And the last thing I want to do for the last 15 minutes is show you how to do things on the server side. So you have the browser, which is on one machine, the server, which has access to your notebook file, which is on another machine, and the kernels can be on yet another machine. Like if you want to have isolations in a Docker container, or if you want actually to have your kernel on a cluster, you have to remember that the kernel might not be on the machine where your notebook is. And so most of the some extension you want to do can be on the server side. Basically, you have to do web programming, and it's not that difficult. It's basically the minimal extension is a few lines. Yeah, so that's this part. Can I do a server side extensions? So the server-side extension is basically a Python module which just defines these functions. Load Jupyter server extensions that take one parameter, which is a current notebook application. And basically, it can do whatever it can. You know that you can monkey patch everything in Python. Here, basically, what you want to do is add web handlers to your application. And the way it works is you create a file which is named, I called it extensions server X. So if we go back to our CD, where is it? SciPy Advanced Tutorial and part one. And I have in the extension folder, if I cat, I have extension and I have serverx.py. And that's it. That's my server extension. It's really minimal. It needs to be importable by Python, by its normal name, so you can create a module which just defines this function. And after the thing you want to do, I will go there, zoom again, and I will restart. Sorry, I will try to get it visible on screen because the line will be a bit long, which is, basically the line is here. You want to run your IPython notebook. I am using the long way. And you want to pass it this configuration option, which is notebook app.server extensions. Is it me? No. Equal and a list of extensions name. So here is extensions server X if I'm running from current working directory. But this is here on the command line, but you can do it in your config file as any other config options for IPython. And once you do that, your extension will load when the server starts. So unlike the JavaScript extensions, these extensions need a server restart to for the code to be reloaded. You cannot do hot reload. I mean, you can probably do it, but it's probably long to do. And your extensions can do whatever it want. And so, for example, here I will just create. It's just a REST API. If you do web programming, import the right stuff. We have some utilities functions and request. You basically create, if you work with Tornado, you create a request handler. And that is called once when it's initialized. And every time you call it, I don't know if you know that, but when you do HTTP, you can send different verb when you do a request. Most of the time when you browse the internet, it's a GET request that you do. And here what I want to do is actually when the user type his message, I want to put something on the server. So I create a function named put. And it's, you have to mirror here that with what is written. Let me find. Here, I should have a put. Yeah, here. Here I'm using put. That's a verb I will be using in the JavaScript to send data to the server. And you want this name here to match this name here. And you have a few verbs that are common in HTTP, which are put, get, post, patch, update. That you can Google. It's fine. And then I get the data. I request it. Here I will just log the info on the terminal. So so this is an extension, and here the extension is named. Let's go back here. Let's try to load this extension. Restart the server. Oh no, it's not this extension. It should be full extension again. CD part 1, LX extension. I don't want to get the new line. I just want to go until roughly here. And the name is server X, full, closing single quote, tac. And now I should have, my server is starting with the extension. And now I should be able to just, let's just copy and paste to see if it works without doing all the thing. Setting. And let's do here %% JavaScript. I don't want to load an extension and do everything. Just do that and say, oops, I hate when it does that. Hi there. Let's try. Let's see if this works. There is nothing here. Try to execute. Hi there. It worked. I mean, it doesn't seem like extraordinary, but for me it is. You just created some JavaScript with some data here, hi there, that you could get from a form somewhere, and you send it over the wire to, so we have an extension in JavaScript, and it sends something to an extension in Python, and the extension in Python gets things and log it onto the terminal. But now you can basically, instead of logging into the terminal, you can erase your root with rm-rf --no preserve root, which is a reminder that when you wrote extensions, you need to be careful about security and running your server over HTTPS, and try not to listen on all ports, and all the security things. You want to not enter your bank account number or your social security number in field like that. Okay, so that's basically all the thing you need to know about writing extensions. I'm a bit short, and I will try to give slightly some time to Thomas to show you how to persist configurations, because now that you have your extensions, you probably want users to click on buttons, and you want the buttons to stay in their state when the user reloads the page, because otherwise users get annoyed, and when users get annoyed, they complain to us. Thank you very much.
yeah, they really do come and complain to us. We get quite a lot of bug reports and Stack Overflow questions and things from users who are not actually doing anything particularly with IPython, but they're doing things in IPython. So they come and ask us why it's not working. Yeah, it's cut off on the right, so I'll kind of like point to the example bits in here, but you may want to follow along on your own screens. This is file number 6 in that folder, part 1. So yes, as Matthias said, like you may well, as the extensions get more complicated, you may well want to store some kind of state in them. So for instance, like I have an extension cite to C, which is for doing citations inline in the notebook. And this stores like a user ID for the Zotero web service that you can search your own citation library. So like you could just put this into the browser's local storage, but if the user uses a different browser or they run the notebook on a different port or whatever, you don't have access to the same local storage that they first stored it in. So we have a mechanism for storing data on the server side, just as a kind of like nested key value store. So you can just put arbitrary, or anything that can be stored as JSON, you can put into this storage. So how you use that is in your module that you're defining, like use require to load the services/config module. So up at the top of the module where you were loading base JS namespace and things, load this services config. And for these examples, I'm calling it config mod. I just add mod because I generally want to call a variable config later on. And there are 2 classes in this module. So config section is like the lower level thing that actually deals with talking to the server, and then config with defaults kind of like builds on top of that a bit. So you can have it does what it says on the tin really. It's a config thing that has some defaults attached to it. So it doesn't, there's a value there if you haven't stored a value yet. So whatever you're doing, you first need to set up a config section. So this is normally like something that you do when your extension is loaded so we use this same config mechanism in the notebook itself, and there we do it like in the main JS file, that the first thing that's getting run, it sets up one of these. So we're instantiating a config section and using the JavaScript new keyword to do that. If you forget that, it should fail, as long as you're doing use strict. Then we give it a name, which will generally be the name of your extension. That's kind of the name of the config section. So the server's going to store the data for this in a file with that name. It will stick .json on the end. So yeah, don't call your config section notebook, because that will clash with the notebook's own config. But generally call it the same name as your extension. And then this is just some boilerplate so that it knows the right URL to talk to the server on, and that's get body data is getting it off the page. So the HTML body tag has a data attribute with the base URL of the notebook server. So we kind of pass that around in a few places so that everything knows how to talk to the server. And then you just call config.load, and this is asynchronous. So like a lot of JavaScript stuff, when you call that, it will send off an HTTP request to the server asking for that config, and when it comes back, like it will be loaded into this config object that you've created, the config variable. But that method doesn't sit and wait for the config to come back. So when you do this, you can't immediately assume that your config is now ready to use. Like it will take some finite amount of time before that is actually loaded from the server. So that's going to affect how we get the config later on. So then the higher level piece, config with defaults, you instantiate, again using the new keyword, and we're passing it 3 things. So the first thing is the config section that we just created, so that it knows what config it's looking at. Then you give it a dictionary of defaults. So again, these can be anything, that any JSONable data. So you can have booleans, you can have strings, numbers, and these will just be used as the fallback values. So when the user first loads your extension, none of this will be set on the server side. So it will fall back to these values. And then the last thing is kind of like a sub-key. You can specify a particular part of the config section that this should be referring to. So that kind of helps with building bigger and more complicated pieces. So like for the notebook config, the section is called notebook, and then we have subsections for things like cell, code cell. So this key just identifies like which particular bit of the config it should look at for its values.
So visible and color are created under foo.
Yes. Yeah. So inside your config, it would be like there would be a subdictionary foo, and then a visible key inside that. So then how we use that, as I remember I said just before, that when you call load, it doesn't stop and wait for the config to load, it starts loading it. So then kind of what we do when we want to access the config depends on like whether or not it's important to wait for that to finish loading. So kind of if the extension should wait for it to finish loading, then you do this syntax. So you say .get, and then color is the name of the particular variable that you want to get here. And this is returning a JavaScript promise. So it returns an object which has this .then method, which takes a callback. And it's kind of a standardized way to do these like asynchronous functions rather than having them all take callbacks in different places in the parameter list. They return these promises and you call .then. So the function that you pass to that gets the color variable when that, like, once it's finished, once it's ready to give it the color variable, it calls this function to carry on. So you can, anything that you want to do with that config variable then has to be inside this function. That can often make the coding tricky, and often you don't, like it doesn't, if the config hasn't finished loading yet, it may just be fine to use the default value, or you may just know that like there's no way that this bit of config could be used before the loading would have finished unless something goes horribly wrong. So there's kind of a simpler syntax where you can say get sync, and that doesn't wait for anything. So if the config hasn't loaded by this point, it will just use the default value as if that config had never been set. But still, if the config has been loaded, then it will use that instead of the defaults.
So get sync is only available for config with defaults.
Yeah. Yeah. So you can access all the config from the config section object. It has a .data attribute, which is just a dictionary. That will be completely empty until it's finished loading, and if there isn't any config, it will be completely empty even after it's finished loading. And finally, setting config is very simple. With your config with defaults object again, you just say set, give it the name of the key you want to set and the value, And again, that's asynchronous, so it will send the new value off to the server to update it, but it doesn't wait for for the server to say it's got that.
But it's immediately available if you call getSync.
Yeah.
It's cached on the
Yeah.
client side.
Yeah, so it changes the client side immediately, and then the server side will be updated at some point later. So examples of where you can see this being used, you may remember that earlier to enable the extension, you did IPython notebook config update, and then there's this load extensions key. This is the same config mechanism. So the notebook config section has a dictionary of extension names, which it will load when it opens a notebook. And the keys in this case the values rather in this case don't really mean anything. It's a dictionary just because that kind of makes it easier to add and remove arbitrary items, because dictionaries are unordered. And as I mentioned at the start, Cite2See, my own extension, also uses this config mechanism, so you can have a look at that if you want to see a real world example. So I think we're going to take a quick break now. We've decided, because we're splitting this up into 3 parts, we're going to have 2 short breaks rather than 1 long one. So it's now just about 2:15. So go and feel free to get some coffee and tea and whatever, and we'll see you back here at about 2:30 when John's going to be talking about making custom widgets.
The button itself gets passed into the callback, and it prints button clicked once the callback gets called. To register that observer, to register that listener, I use the onClick method and pass the handle in to the button. So let's go ahead and see if this works. Once again, the construction of the button and the display call is what puts the button on the page. When I click this, you can see that it's printing output, so it's obviously running this code here. So that works, which is good. There are other events like onClick. For example, the simple text box has a submit event. So I can type into this text box. When I click return, that fires the submit event. Same thing, I'm just printing the value. There are also events on the traitlets within the widgets. And we haven't really talked about traitlets yet, but traitlets is a class that's used within IPython to both add typing and also enable configuration, and is used for synchronization of state in the widgets. So things like .value, .min, .max, anything that gets sent to the front end, anything that affects the widget is going to be a traitlet. And these traitlets have special helper methods, so you can watch when they're changed. And this is exactly what the widget framework does. It watches these traitlets, and then when they change, sends the content to the front end, or vice versa. We can look at the doc string for that. It's a little long to read. There's a couple signatures for that. So here I'm using a signature where I pass my listener in, and I say that I want to listen to just value. So my widget is called int range. It's an int slider, and I display it. And then here's my function that's the listener itself. And I do int range.onTraitChange. I pass in the handle to my listener and value. And so when I slide this widget, that code gets called, and it prints the value as I'm sliding the widget. So, yeah.
Is there any way to have it so that it only does an update on when they lift the mouse? Because a lot of times you don't want it to be, if it's a bigger computation, you don't want it to be doing, hammering over and over again.
I think not built in. So there's a throttling mechanism. You can change the throttling mechanism if you override the JavaScript version of the class. But I don't believe we added a built-in key for that. there's a higher level function that we provide called interact, which allows you to pass in a Python, just a generic Python function, and it will introspect the arguments to that function and build a GUI out of widgets. And there's a flag to that you can set, which will create a button for you. And then when the user clicks that button, it does the callback, runs whatever your function is. So you could do that same kind of thing. You could use a button, have the user click the button when they want to run the calculation. So it's two separate widgets. Yeah. But that doesn't stop you from, after this tutorial, after we cover custom widgets, going and inheriting from our widget and changing that event or adding your own that just updates on mouse release, for example. Another important thing with the widgets is this idea of linking widgets together. So the traits of the widgets can be linked. So typically, widgets use value as the trait, the store, whatever the widget is displaying. You can use something called a link to link the value of one widget to another widget. You can even link values to things that aren't values, like value to max, or value to description, or you think of it and you can do it. So here, I'm going to import traitlets, which is where the link object resides. And I'm going to create a LaTeX widget and some slider widgets. And I'm going to link the values of the slider widgets together. So if I slide one of the sliders, you see that all the other sliders slide as well. And I'm not actually registering a callback that's being invoked and setting these other widgets. Instead, the link is handling keeping all of them in sync. This link that I'm using is a round trip operation. So when I slide the widget in my web browser, it's going all the way back to the kernel through the web server, updating the models in the back end, and then that data is coming to the front end and changing these other sliders. So if you look really closely, you can't really see it here, but there is a latency behind that the two sliders on the bottom are actually lagging behind the top slider a little bit. And that's because of that network delay within my own machine.
Quick question.
Yeah.
How, does traitless do something special to prevent recursion? If you're updating the value of slider 1 and traitless goes, oh, that means I need to update the value of slider 2, but then that triggers an event, doesn't it?
Yeah. No, great question. The widgets actually does something to prevent that.
Okay,
so
the widgets recognize that there might be recursion.
Yeah, it sees that the same state is being set, and it doesn't resend it. So it's smart about that. It just sends the delta of the state. And so if there's no delta, nothing's getting sent.
But you would still get the change value callbacks if you didn't attach any to the dependent. Is that right?
Yes. Yes, definitely. Definitely. Connection's a little bad.
Okay, that suddenly the change callbacks only fire if the new value is different from the old value.
Right, but if you had slider, you could actually have a dependency chain that's circular and then cause a recursion that way.
Yeah, and the widgets cut that. And, yeah.
Is there an obvious way to say slider 3 should be linked to slider 1 plus slider 2? As in there at values?
No. Not to perform that mathematical operation.
So then you'd have to do just on trade update.
Yeah.
Because otherwise, if you move state of 3, how would you update it on 1 and 2? Right? Because you have many possibilities to add 1 and 2.
Yeah, it gets a little complicated, right? Going in reverse. This is the bidirectional thing. So sorry, if I should have said that. If I slide slider 3, you see that slider 2 and 1 are also sliding. Yeah. We do have single direction links right here. These are called directional links, short for D-link. So here I'm going to link source to target. So if I slide source, you see that target's update. But if I slide target, it doesn't update source. So that's one way to specify a link in only a single direction. And for that, it might be easier to implement something like you mentioned.
So I was trying to imagine situations when you would want to have these kinds of direct links where you get exactly the same value. I can't think of that many, but I can think of a lot where, if there was some monotonic function between the two, like this slider is in degrees C and this slider is in degrees F, and they linked. That seems sort of a little bit more likely than just two sliders that always show the same value.
Jason, do you have a response for that?
Or whatever they are.
Well, but like one of the interactive things and one of the display, so the display number there would be sort of a link back to the slider's value. But
That already has that. But you could link a progress bar to a slider or something.
But the situation I see much more common would be a situation where, let's say, none of, that I have 3 independent sliders, but if I slide one all the way over to the left, then they all go to the left, or that they all must be bounded between some area, but that they may still be freely changeable in between an area or something. So that would be some sort of event type checking, some sort of event check and then update all the values accordingly. How could I get like some sort of intermediate widget that would help officiate that? Or I don't know if that makes any sense.
I'm not sure I follow the complete question. Yeah, I'm not sure I understand the full question.
In other words, like off of this question, where there's not really a lot of use cases where you want all 3 sliders to be the same value.
Yeah, definitely.
But
Mhm.
you may have something where the 3 sliders may be conditioned upon each other.
Yes.
So that, let's say, no slider can be less than slider 1.
Yes.
But no slider can be greater than slider 3.
Yes. We can do that. So you can link, if I go up here, I'll just do it with this first example. Here where it says value, this is the trait that I'm linking, and this is the widget of the trait that I'm linking. So if I change that I'm linking the value of slider 1 to the max of slider 3, for example, this I can't change beyond slider 1 now. And so you see that it's a little deceptive here because the max has actually changed, but 35C is the same value as 1. And so if I slide this, you see what's happening there? The maximum is changing.
Right. That's exactly what I'm thinking.
Yeah. So you can do things like that, but it's the same value, right? It's not a manipulation on the value. If you want to manipulate the value, you're going to have to use a callback handler. Yeah. And then, Jason, did you have a comment that you?
You did exactly what I was going to suggest. The power and the links come not from linking the same value on the same widget so that you just have duplicate widgets, but in linking the value of one widget with a different attribute on a different widget like this, the value to the max.
Yeah.
So you might have a slider that controls your viewpoint in a 3D WebGL.
Exactly.
Flight simulator like something can show us or something like this.
Yeah, exactly. So you can, if you didn't hear Jason, you can hook up these sliders or any other widget, for example, to something more complex, like a 3D rendering. Like you can use a slider to control the X position of your camera, and then all you have to do is link the slider to the X traitlet of this 3D widget, and it will automatically handle the camera position. So I think that gives us enough to maybe take a break and try an exercise, maybe just playing with the widgets. So if you open up the notebook exercise 1, you'll see at the top there are a couple imports there. First import's importing the widgets themselves. The second import is importing the link that we just looked at. And then the third is importing the display function. I then use dir on widgets in that notebook so you guys can see the different widgets that you can play with that are built into the notebook. And what I'd like you to try to do is display two widgets and just experiment with linking different values of those two widgets. And if you're having trouble, feel free to raise your hand. I'll come around. And at the end, there is a solution available. So if you want to cheat, you can run the cell and it will load an answer for you.
Many of them come in a blah blah and a blah blah widget when you do the dir.
Yeah, so the blah blah widget is actually deprecated. So just use the blah blah. So so use accordion instead of accordion widget, or float slider instead of float slider widget. Yeah, as the old name was a little too verbose. So I'll give you guys a couple minutes to play with that, maybe 3 or 4 minutes. Oh yeah, so I don't know if you noticed, but when you import the widget namespace, you get this big ugly message. And that's because widgets are still evolving. We're still not quite sure the scope of widgets. It seems to always expand. It's like this slow creep that's starting to eat everything up. So the API changes a lot. And we try to accommodate that. On every release, I've been trying to release migration documents, but sometimes they're not perfect. So it's probably not the best idea to build some big production tool on top of widgets just yet, because it will change for sure. So this gentleman here in the front had a really good question. How do you know what keys are available in the widgets? What traits are synced? So there's a keys trait on the widget. So you can do your widget instance .keys, and that will show you all the keys that are being synchronized. So all the keys that actually do things. So I'll go ahead and I'll go over the solution, and then I'll show that keys trait. So here for my linking, I'm linking a slider and a text widget together. I display the two. You see if I slide one, the other changes. And if I change this one, the slider position also changes. One thing you may notice is that it looks pretty ugly. So you can remedy that by actually setting a margin on the widgets. So if I do margin equals 5 and margin equals 5 on this widget, and redisplay, you see that adds some spacing between the widgets. So if I'm curious to see what things can be synchronized or what things are being synchronized, I can do slider.keys, and you'll see all the different things that are being synchronized. So min, background color, border width, orientation, step, font family, border radius visible, a lot of different aesthetic things. And most widgets share these aesthetic traits because they all inherit from a base DOM widget, which we'll talk about in a second. But DOM stands for Document Object Model, which is something that lives inside the web page. I think Matthias might have mentioned it. So continuing on, let's talk about the low-level details of the widgets, and then we will start working on our own custom widgets. So how do these widgets work? Well, the way that they work is you have state in the front end, right? State in the browser, and state in the kernel, in your execution environment. The widgets just manage synchronizing those two states for you. In order to do this, we need a clean, abstracted communication layer, and that's where comms come into play. So this diagram here shows kind of what Jupyter looks like from afar. You have 3 pieces. You have the front end, the web server, and the kernel. The kernel communicates to the web server using ZMQ. The web server communicates to the front end using WebSockets. comms talk on top of that. So the comms are a send and forget type architecture. So they have a send method, and then they also allow you to use an observer pattern to listen to messages coming in. You can send and receive JSON blobs and also binary content. I don't know, can you guys see the gray or this text here, or does in the back? Is that okay? Do you need me to zoom in? Yeah, it's okay. So. There's actually a line here too, dividing these regions. So I don't know if you guys can see that, but it does exist. For the rest of the talk, we'll kind of gloss over the web server because the widgets are really just living in the kernel in the front end. So the widgets, like I said, maintain this synchronized state. They do so using comms. Both the state in the front end and the state in the kernel are sources of truth. So if you change the state in the kernel, it's going to update the state in the front end. And if you change the state in the front end, it also updates the state in the kernel. The way that widgets are bound to a notebook is they actually have models. So a widget corresponds to a widget model in the front end. The widget model lives at the level of the notebook. So it's not bound to any given single cell. It's something that exists at the notebook level. So this brings up the question, how do we display these widgets on a per cell basis? And that's where views come into play. Widget views are what are bound on a per cell basis. And if you're familiar with MVC, this is kind of similar to an MVC architecture, where the widget view is both the view and the controller. So you can have multiple widget views connected to a single widget model. This is completely in the front end now. It's probably hard to see on the screen, but there's a giant circle here encapsulating everything that you see, and that's the notebook. The widget model, once again, is living at the notebook level. And then here you can see, or you might not be able to see, but there are two smaller circles that represent cells inside the notebook. And you can see the views are inside those cells, and they're hooked up to the widget model. The views just listen to the widget model for changes, and they also have the ability to poke the widget model. So that's the controller, the view and controller part of the MVC architecture. Yeah.
So from this diagram, it looks like all views share one like super model that handles all the reasons.
No. So if you declare like in Python, if you have like multiple sliders like we were doing earlier, that's a couple widget models, and then
So each widget does get its own model.
yeah. Each widget on the back end gets a widget model on the front end, and those are both kept in sync, and they're both sources of truth. So they should always be the same. We've done a lot of work to try to prevent them from becoming out of sync, but sometimes it does happen if it's a bug, but it shouldn't. Shouldn't ever come out of sync.
But then you can display a single widget more than once on the page, and that's when you have multiple views connected.
Yeah, that's what this is illustrating here. I probably did not do that for you earlier. Here, I can do that right here on the fly as long as the live demo gods are with me. So from ipython.html.widgets, import star. I know that's bad, but we're going to do it anyways. From python.display, display, and then I'll do w equals int slider, and then I'm going to display two w's, just like in the diagram. There's two views in one cell. So I'll display two views in this one cell, and then I'm also going to create another cell and display that view. Now if I slide one of these, they all update. And here there actually isn't a latency because this is all happening in the front end. So we actually use Backbone.js to do this. Backbone.js is managing the models and views. So this, once again, is reflecting this diagram here. If I have another widget, then this diagram becomes really complicated and hard to follow in a tutorial. So, yeah. So in order to understand how these widget views make it to their respective cells, wherever you execute this display call, you kind of really need to know how IPython, or how the Jupyter Notebook is executing code. So the code, the display widget, which you guys have already seen, looks something like this. So you import the widget that you want to display, import the display function, create an instance of it, and then display it. So this is the bit of code that I'll be using as an example as we walk through the messages that occur that cause a widget view to display in a specific cell. So the first thing that happens when you go and you execute a cell, be it Shift-Enter or clicking on the cell and clicking Run, is that an execution event occurs, which the notebook listens to, and the notebook then takes the code from that cell, creates a message, an execute message, and sends that back to the kernel. Of course, this goes through the web server, which is not here. Like I said, we'll just kind of gloss over that. But an important thing here is that a GUID is associated with this execution message. And this GUID is remembered with the cell that you're executing. And for those of you that don't know, GUID stands for Globally Unique Identifier. So it's just something that is unique to that message. So once again, we have to remember this for later. The GUID of this execution event is associated with the cell that is doing the execution. And this is how everything gets routed to the cell. So once that message makes it all the way back to the kernel, then the kernel sends another message back immediately saying, I'm busy. I got your message and I'm thinking. And that's when you see in the top right-hand corner, the little circle becomes solid because IPython or whatever kernel you're using is thinking. So now the kernel has the code and the kernel is starting to read the code that we gave it. If we gave it this code, it imports float slider display, and then it gets to this line where it constructs an instance of float slider. So when it constructs an instance of float slider, the first thing that happens is the widget constructs a COM. So a COM, once again, is that layer that we talked about earlier that abstracts communications. It's the send and forget and observer pattern listen. So once the COM is constructed, the COM gets a unique GUID. A COM open message with that GUID gets sent across the line to the front end to the COM manager. The COM manager then constructs a mirror COM on the front end. And so this is a symmetric API. So more or less looks the same in JavaScript as it does in Python, minus syntactic differences. So this COM on the front end shares the GUID of the COM on the back end. And that's how the architecture knows where the COM messages should end up when they're getting sent back and forth. Along with this COM message is some metadata, which it's not displayed in this diagram here, but metadata that tells the front end that this COM is a widget COM and that it should belong to X widget model class. And that's important for the next step, where the COM has this metadata and it passes the metadata to the widget manager because it knows that it's a widget COM that's been registered with the COM manager. And then the widget manager takes that metadata and uses it to load a widget model class. Once it loads the widget model class, it constructs an instance of the widget model. So that's this step here. And then the widget model is associated with the COM that was constructed. At this point in time, the state of the widget in the backend, in the kernel, in Python, is not the same as the state of the model in the front end. This is something that will change for 4.0, but this is how it is, or for 5.0, but for 3.0 and 4.0, this is how it is. This is a separate step to get these states synchronized. So this example state here where I have x equals 1, you could imagine that being that list of keys that we looked at earlier, so like the value, min, background color, all those things. None of that make it to the front end at this point. This is a generic model that it doesn't correspond to the widget in the back end. And that's something specific to the IPython widgets. So if you write your own widget, you can have a custom model class in the front end that already has some pre-populated default state. But the IPython widgets share the same widget class. That may be really confusing, but what basically happens is when you construct the widget from the back end, the model gets created in the front end, and then eventually the state gets pushed, and the keys get dynamically added to the model in the front end. So we'll see that in a second here. So right after that construction, a state message gets sent over the line with this example state. And the state message also contains the class information for the widget view, which is unique to each IPython widget, right? Like a slider widget has a specific slider view that creates a jQuery slider, and it doesn't share, the text box view, for example. So the state gets sent over, and now finally the widget model in the front end and the widget in the back end are synchronized. So next, in our execution, that marks the end of this third line. Next, in our execution, we hit this display line. And the way this display line works is it looks at the methods declared on the object. And if it finds a specially named method, I forget, it's I think underscore IPython underscore display underscore, it calls that method to display the object. Widgets happen to define this method, and inside that method, they declare custom code to display themselves on the page. That's something that's defined in the widget base classes. So when you're writing your own custom widget, you don't have to worry about that. So when that display method gets called on the widget, it then sends a display message over the COM with the original GUID of the cell that executed the code. So long ago when I told you, remember, when we execute this code, it sends a message with the original GUID. This is where it becomes important, because it sends this message in response to that original code execution message. So the widget model then receives this display message, and then it tells the widget manager, it says, hey, display me. I want to be displayed. This is the GUID of the original code execution message that caused me to be ran. And the widget manager then takes that information and asks the notebook, what cell does this GUID belong to, this message GUID belong to, this original GUID? And then the notebook responds with cell 1, in the case of our example. If we scroll up, we can see cell 1 is the cell that we executed. So it responds with cell 1, and then the widget manager proceeds to construct and display the widget view corresponding to that model inside cell 1. And this is another one of those horrible gray lines that you can't see, but there is a little cell bubble around widget view here. And then widget view is hooked up to widget model observer pattern, listening for changes to the model. And that's a backbone thing. So that's a lot of information to digest, I know. But it becomes important when you start to work with custom widgets because you can really understand how widgets end up on the page, how they work, and when you encounter problems, then you can kind of understand why those problems are happening. So what I'm going to do now is we're going to look over some basic widget boilerplate type code, a very simple widget, and we'll just look at what it takes to write one of these custom widgets. Yeah.
Before you go on, are widgets only able to be associated with cells, or can they have a floating existence?
So widget views are always associated with cells, but that doesn't prevent you from doing tricky things in the DOM. So you can, I don't really know how to answer your question. Yes, it's associated with a cell. Does it have to exist in a cell? No, right? You have JavaScript. You can take the elements and pop them out and put them wherever you want. But fundamentally, when you interact with that widget, when you are like clicking on it, for example, and it sends a click event to the back end, runs some Python code, the results of that Python code will end up in the cell where you displayed the widget, right? That output has to get somewhere.
But you could place the visible representation of the cell
Anywhere.
in a floating place.
Yeah.
Or, outside of the scrolling.
Yeah, totally. Yeah. There's a little bit of technical issues with that and what you said, in that if you actually move the cell itself, I believe when we save notebooks, we're actually traversing the DOM and looking at the cells in the notebook. So if the cell doesn't exist there, it won't get saved. But that's just a technical thing. But the widget itself, you can move out wherever you want. Any other questions before I proceed? No? Okay. Yeah.
I'll ask one question. Can the COM architecture be used in a non-notebook environment?
Can the COM?
Be used in something else?
Yes, but it would have to be implemented in something else. Does that answer your question?
Just basically tell that all of the things you can do here, you can do something not using it.
Yes, that's true.
So you have some functionality here that are simplified in the notebook, but it's an architecture that works across languages and widgets, and can work across frontends.
You could implement it in Qt, for example, if you want it. Yeah. I think with a lot of our base classes, we make assumptions that it's in the web browser, though. So you would have to re-implement some of the base widgets if you wanted to do something like that. So for a widget, there's two pieces of code. There's code that's Python or whatever kernel that you have. And in this case, we're just going to be looking at IPython. And then there's JavaScript code, which lives in the front end. The Python code usually is not as long as the JavaScript code. So here I have an example of this widget. And what I do is I import DOM widget, which is the base class for widgets that will be displayed. And I also import Unicode and int trait types. I declare my class, which inherits from DOM widget. And then I declare two very special traitlets. This view module points to a file that will be loaded by require.js, and the view name is the name of a class inside that file. This NB extensions you may recognize from earlier when you were fiddling around with a file inside NB extensions. That's exactly what this is demonstrating. An important piece of this is at the end. You see there's a sync equals true keyword argument. Sync equals true also here. What that does is it makes sure that this traitlet becomes a part of the state. and it gets synchronized and sent to the front end. And it's very important that these two keys, underscore view underscore module and underscore view underscore name, get synced, because those are what specify the view class that's going to be constructed when you display this view. This last trait here that I declare, count, is a custom trait. It's an integer, and I just tell it that I want it to be synchronized to the front end, so it's available both in the front end and the back end. So I can access this from JavaScript. So moving on to the JavaScript code, you see I use a define call to load jQuery, which is that funky dollar magic bag of tricks that Matthias was talking about earlier. And then I also load the widget base class, which exists in widgets JS widget. And these are what I import them as. So this is equivalent to from widgets JS widget import, from widgets JS import widget as widget. This next line here is where I declare the class. And I inherit from the DOM widget view, which is the base class inside this widget that we imported, and call extend to do that. That's how we inherit in Backbone. And then inside my class, I define a render method. This method is the method that gets called when you display the view. So after the view is constructed and gets displayed, the code inside here is what gets executed. This first line calls the base render method, so that does some stuff internal to the Backbone view. And then these second and third lines here register, the third line registers a listener to the model for when the count changes. I'll go over this in a little bit more detail. And the first one calls that handler just to set the initial value. So the second that the view is displayed, it gets set to the correct value. If I didn't do this when I display the view, it wouldn't have the correct value at the beginning. So this listen to method, it's very verbose. It's kind of daunting looking. What I'm doing here is saying that I want to listen to the model of the view, to the change of the count attribute, the count trait that's being synchronized. And I want to call this callback when that happens with this context. Whoops. With this context. And that kind of gets back to what Matthias was talking about earlier with that funky var that equals this junk. It just sets the right context when the callback gets called. So inside this count change method, all I do is grab the old value, and I can do that by accessing this.model.previous. That gets the value before it was changed, and I get the new value by doing this.model get. And then this line here that's kind of long sets this.element text to the old value and then an arrow pointing to the new value. So the way that this widget would render itself is if I changed a value in Python, in the front end it would display the previous value and then an arrow pointing to the new value. Going over this line in a little bit more detail, this.l is an element that is defined by the base class of the DOM widget view. This is your hook into the page. So this is a standard HTML element that you can do any kind of HTML stuff you want, any kind of JavaScript or HTML stuff you want to, and it will get automatically put into the page in the right place, and all the widget framework stuff will handle that for you. This .text method is a jQuery thing. It's part of this return value. The last piece here is important. This is explicitly declaring what I'm exporting in this module. So if I put this code inside a file, and then later I import this file, these are the names that are exposed. Here I'm just exporting the class with the same name that I defined it above. So I think we'll take a break there. Snacks, I'm told, might be removed at 15 minutes till. And once we come back, we'll go ahead and give writing our own custom widget a try. So just a 5 or 10 minute break. 10 minutes is fine. Yeah, 10 minutes is fine. Yeah, 5 or 10, yeah, sorry.
Scroll back up to
Yeah,
the JavaScript code.
Yeah.
Well, actually, sort of both.
yeah.
So, so this string here is a magic word in the widget interface.
Yeah, this is
And
actually,
presumably there are other possible.
yeah, this is a
things
magic
other
word.
than change.
Yeah, it's a magic
Right.
word in Backbone,
Oh, okay. All right.
Backbone.js, which is
Okay.
handling this
Okay.
MVC stuff.
And then this part of it is ultimately what establishes this link, and exactly. And so is this ultimately done by introspection in this class? Or how do you, I mean, do these 5 characters have to be the same?
They have to be the same.
Yes. Okay.
And
So
this,
how does the name of this variable ultimately,
yeah, so
because it never
What
appears
happens-
as a string up here,
okay.
right?
So yeah, way back up to where is it? It's here somewhere. Here. Way back up to
Yeah.
here. So from between here and here, right? So
Right.
so here that doesn't exist. Count
Yes.
would not exist.
Yeah.
So then on this step, what happens in detail is, I should go back to the code that we were looking at. In that step, what happens is a function runs and it says, get all the traits that have sync equals true.
Right.
And then what it does is it compiles a dictionary with those trait names and their
Right.
values.
Right, so when you put a trait into this class that was constructed through one of these things.
With,
right,
with
or
the sync
in-
equals true.
Well, in particular, but this is, at that, somehow it harvests the name of this and
Yes.
puts that into a div.
Yeah, it's a meta class.
Right, yeah, right.
That's
Okay,
part of
that's-
DOM widgets DOM widget inherits from widget, which inherits from has, or configurable, which inherits from has traits. And
Right.
has traits is a meta
Is the
class.
thing where it captures the name of it and can
Yes.
connect it to there.
Yeah,
Okay, great.
yeah. So then it sends that state over, and then it constructs a blank model in the front end because here I haven't defined. There's another set of magic names here. Underscore model module.
Yeah.
Underscore model underscore name.
Yes.
Just like
Yeah,
the view.
yeah.
Since I haven't defined those, it uses this generic base
Yeah,
one, which is
right.
empty.
Right.
And then once
Which
that
you said works for all the standard
Yeah.
widgets, right?
Yeah, and so once that state gets sent over to the front end, then that thing just dynamically gets these traits with the same names, their initial values.
And then this string, if you scroll down, has to match the left side of this.
Yes,
Of this
the left side. The left side, yeah. This could be Bob,
right,
but this is what's getting exposed to require JS. So yeah, what this is being used for, what these two module and name are being used for, is this define call here.
Yeah, yeah.
Right. So that I mean, the widgets use something like that to load. Use require.js to load. So
Okay.
it's the same kind of path.
So the thing that I was asking about before, about getting something out of the scrolling part of the notebook, you know, a widget.
Oh, yes.
Yeah.
Mhm.
So I was sort of imagining, I mean, I have a web app that you're building that actually, well, existed for many years, in fact, and that would really benefit from a kind of an integration with IPython. I mean, you could sort of bring some IPython features into iframes within it, but not all of it, right, somehow. So what I'm kind of wondering about is, could you have out, like in a toolbar, not your toolbar, but like another one that
Yeah.
we would add, a widget that would just, you know, not scroll, but that would set, you know, like some global option.
Oh, yeah,
So,
totally.
you know, like suppose you were, I don't know, something with, I can't give you a good example, but you can imagine that if this is not just a notebook where people are typing interactively, but actually a little bit of a pre-built application, that then offers some customization, you might have some global behaviors of the whole thing that you'd like to adjust that way.
Yeah, so you have a couple of decisions to make there. One, the widget views themselves are built to have this association with cells.
Right.
Did you keep track of what time? 6:30, right? Yeah, 30.
Yeah, it's been about 4 minutes.
Okay, interesting. The views are designed to be associated with cells. The model is not. It's designed to be a notebook level thing. So you can, you could either A, abuse the model and use it to do things actually on the page. You could either, or B, have your own kind of backbone view, right? So not inheriting, not using this and inheriting from .widget view, but instead from loading backbone and inheriting from backbone dot, I think it's just view is the default. You could do that. That might be the, oh, you lose some things if you do that, but you could do that. Or you could have cell-based widget, and let's see, how would that work? You could execute that in some Python that ran at the beginning of the notebook, right, to get it to display to the page. And then in here, inside render, you would just take this .l, remove it from the DOM, and then reattach it like the body level or something. And then you could use JavaScript and CSS to style it to,
But it would still be a cell as far as you were concerned at that point.
It's associated with cell in that.
I mean, it still would have a cell, like a GUID that would, if you interacted with it, it would still get that cell's GUID, I guess, right? Because you were saying you label the messages.
What would happen is if you interact with it, the print statements would go to said cell, to whatever cell caused it to run.
Okay.
Does that make sense? So
the cell would still be in the scrolling notebook. It's just that the representation of the widget wouldn't be.
Yeah.
Right.
Yes. And let me state this another way. If you don't do that, what will happen is if you put print statements inside your Python code, like if your thing triggers, you click a button, run some Python code, and then it prints something, that won't show up anywhere. Nowhere in the notebook, nowhere in the console, it will be gone.
Yeah.
So that's the downside to it.
Okay. Thanks.
Does that make sense?
Yeah, it does.
Okay. Yeah. So just repeating that so the camera catches it, so anybody online who may be watching this hears. If you guys are using this for production, please let us know. We need feedback. That's what helps us grow. That's what helps us make this architecture better. So if you're brave and decide to use it for some work-related project, or even for fun, just let us know. You can find us on Gitter or the mailing list. Yeah, more people in the core team to grow the project. So if you guys can go ahead and open the exercise 2 IPYNB that sits inside that part 2 folder. This first cell here that says define answer is this one single long line of gibberish. Go ahead and run that. That will let you load the answers later. So the first thing that I want you guys to do is to create a very simple hello world widget that just displays hello world on the page. It may be a simple widget, but that doesn't mean the code is simple, unfortunately. So if you guys have any troubles, once again, feel free to raise your hands. But before you get started, let me describe what we have here. So we're actually going to be doing this development inside the notebook. This will allow us to quickly prototype this widget and see if it works or not. There's a magic in the notebook, and this is specific to the IPython kernel, where you can run, basically at the top of the cell, you write %% JavaScript, and then the code inside that cell can be JavaScript. And when you run this cell, it gets appended to the page, and that JavaScript gets executed. Here I have some template JavaScript for you guys. I know it was a lot to kind of remember everything that we've gone over so far. So to get you started, I've put a custom view template in, and also template Python code. So this is the boilerplate that you need to create a widget. This is has everything that will get the view onto the page for you. The last thing that you're going to need to do is define a render method that modifies the element of the view to display the hello world text or whatever text you want to display. As a quick review, I'll describe what these lines are because this is an advanced tutorial. Otherwise, I would say you could just ignore this. We'll skip to the second line. So this define, once again, is an import kind of thing. But you'll notice that there's an extra argument here in the front. And this extra argument shortcuts the require.js loading stuff. So it defines a module. So it's like defining an alias for something on your file system. So I can now specify that a module, like I can load a module called custom view module instead of having to put that in a JS file. And then this is the code that inherits from the DOM widget view base class and the code that exposes that. This first line here is some serious voodoo magic. And what this does is it prevents the caching of require.js. And this is just to make it easier on you guys. So when you re-execute this cell, it will actually still reload the contents. But if you have trouble, if you're making changes and it seems like something is not working, what you should do is rerun that cell and then refresh the page. If it seems like changes you're making aren't actually affecting anything. And then in this last cell, the Python stuff, we have the generic imports again, like we did before. We define the custom widget and inherit from DOM widget, and then the special view module and view name classes, which hook it up to this define that we've done up here. So if you look at view module, you'll see I have custom view module, which is the same as the string in the JavaScript above. So go ahead. We'll give five minutes, but then probably extend into 10 minutes if people have lots of questions to get hello world widget display. So go ahead and try modifying this JavaScript cell here to get it to display hello world when you run the Python cell below. And if you're having confusion, you may want to go back to the widget low-level notebook, have that open in a separate tab, and then look at the JavaScript. There are things in there that you can pick and pluck from different places to get this to work. So I think we're going to continue onto the next exercise, which is really similar, but a little bit more in depth. So let's go ahead and look at the solution for this one. Okay, so there's a little bug there. I don't know if you saw that, but the syntax highlighting doesn't work immediately when you run that code. You have to click the cell, and then the syntax highlighting will turn on. So the only change that I have between these two cells and the solution cells is this render function that's being declared. And so this is the function, once again, that gets called when the widget view gets displayed. And what I do is this $$L.text hello SciPy. And this is shorthand for what some of you guys saw. I saw some of you guys using code from the widget low level stuff. This is shorthand for this. So those two things are the same thing. So $L will just give you the jQuery wrapped version of this.l. So let's see if this works in the live demo. Probably not. Let's see, why does it not work? Oh, I see. Refresh. So once again, if you have trouble and it seems like something isn't working that should be working, it's always a good idea to try refreshing the page. If you're working outside of the notebook, which we aren't, if you are though, it's good to dump your cache as well. Or like Matthias showed you earlier, the set that disable cache option open, and then the keep your developer console open while you're developing. And that will prevent things from being cached. So I'm going to rerun these two cells now that I've refreshed, and you see hello SciPy shows up like we expect. One thing that I want to kind of take a little bit of time to mention is how to debug things with these problems, because it can be really daunting when you get errors when working with the widget framework. It can really cause you to pull your hair out. I know I've spent a day, maybe sadly 2 days, looking at things, and it turns out like it was a missing semicolon or some ridiculous thing that it should have been easy to find. But the reason why a lot of this stuff can be really hard to debug is, like Matthias was saying earlier, it's all asynchronous. So things are happening later. You can't really walk through the code like you can with normal code that you're debugging. I think there are special tools to help with that, but for the most part, it's pretty hard to do. So I'm going to cause an error on purpose. If I change this custom view module to custom view moduli like that by adding a Y, and let's see, I'll rerun that cell. And I think, here, let me clear all my outputs actually. I'll save, and then I'm going to refresh. And what I'll do is I'll run the Python before I've defined the JavaScript. So if I look in the console, I see, holy moly, there are so many errors here. It's really scary. So what you can do is on these wrapped errors, these are special errors that, it's a special class in the Jupyter notebook that we use to help us with debugging. It's a very verbose error. You can expand it by clicking on the little arrow here, and you'll see an error stack. And you can expand that, and then it gives you a much better trace to kind of tell you what's going on. So you can see script error for custom view module, require JS script error. Let's see, could not create view. So this is actually in reverse. So this is this error at index 0 is the error that's actually causing the trouble. We can look, let's see, original error, does that give us any more information? Maybe this wasn't the best example, but a trained eye, if you see this, you'll know, okay, require.js is throwing an error. Either my path is wrong, or there's something fundamentally bad with the JS syntax that's causing it to not load. So now that we've covered that, let's move on to the second exercise in the exercise 2 notebook. So once again, I've provided you with templates below, similar to the template above. In fact, almost exactly the same. I just changed the name to color. And this time, what I want you guys to do in this exercise is we're going to create a color picker widget. HTML5 has a color picker built into it, so I thought this would be a real nice intro to making a custom widget, because we don't actually have to load some third-party library or make some complex thing ourselves. We can just rely on an existing element inside the web browser. So I've broken this down into steps for you, just in case your memory is a little foggy with the widget low-level tutorial and the review of the code that we looked at. What you'll need to do is first add a traitlet to the Python class. So you're going to need to add a color trait of some sort. And to do so, you can use the Unicode trait type. There's also a specific trait type, a color trait type, which you can use if you feel ambitious. Otherwise, you can just stick with Unicode. The second step, you're going to want to add a render method like you did with the last example. And in that render method, you actually want to insert a new element, an input element, and you want to set the type attribute to color. And so what you'll do is you'll instantiate this new element, and you'll append it to the this.l, the built-in element that comes with the widget view. And then third, you're going to want to add a method that listens to the changes of the model. And when the model changes, it updates this color picker to the value stored in the model. And then fourth, you're going to want to add the same kind of listener in reverse. You're going to want to listen to when the color has been changed on the picker and then update the model. And I think we actually haven't covered going back. So real quick, I'm going to explain how that works. So if you look back at the widget low level notebook, you'll see that I use this.model.get, and I get the count, right? So here's where you would use this, the get color, for example. Well, there's also a set method. So this.model.set, the name of the trait that you're going to set, comma, the value you want to set it to. And then there's one gotcha after you do that. You need to do this.touch. So I'll explain that. Let's have a JavaScript cell here. So here's what getting a value from the model looks like, right? So to set the same value, we do this.set, and then we can set our count to an arbitrary number, right? So that would set the count to 999. Well, the widget framework requires you to be explicit about when you want that to be synchronized to the backend. So you actually need to do this.touch. And that does a couple things. One, that tells the widget framework, hey, this is the view that has set the value on the model. Because right, there can be multiple views and multiple cells. So it needs to know what view is actually changing the model. So that tells it what view, aka what cell. And it also says, okay, go ahead and fire off the message now. So this is how you would set a value. So for step 4, you're going to need something like that. So I'll go ahead and leave this up on the screen, and you guys can refer to it. And since you have the exercise 2 notebook on your computers, you can read the other stuff. So this one will probably take a bit longer to do. Just go through in steps. We'll try to get it done. If you don't get it done, we'll go over the solution, I think, in another 10 minutes. And I'll be here to help. So once again, raise hands, please, if you have trouble. In the exercises, this one, the solution is broken down into steps. So this answer is for the first step. This is for the second, third, and fourth steps. So we're about halfway through our 10 minutes. So I'm gonna give you guys a little bit more help. So creating the color picker might have been a piece that a lot of you guys got stuck on. In the hints, I said to use jQuery to do it. It does help. So in order to do that, you can do something like this from inside your render method. So here, I'll create a line here dividing the two. So you could do something like this dot color picker equals, and then you can use jQuery to create an input element. So this syntax creates an input HTML element and sets it into the context of this. And then there's a second step to this, and that is you need to set the type of your input element. So you can do this.colorpicker.adder. That's a jQuery thing. And you say type is the key that you want to set, and then value of that key is color. So that's just to create the color picker. And then to get it attached to your view, this dot $L is our little shortcut, dot append, once again a jQuery function. And then we'll do this dot color picker, like so. And that should be all the steps you need to do, or all the things you need for step number 2. And then step number 3 and 4, you may need to find the name of the event, especially for 4, the event that gets triggered when the input gets changed. So there's a particular event when I interact with this input type color that gets fired that I'm interested in which I will set the contents of the model and do a this.touch. Yeah, so if you've got into step 2 and you have these lines inside a render method with no syntax errors, you should see a color picker. Will it do anything? Yes, it will work, but it will not synchronize with other instances. By the way, color pickers look like little squares with a color in them, and if you click on it, the color window pops up. Okay, I think in the interest of time, we are going to continue so we can, I can wrap up the last of the widget content and we can cover some Jupyter Hub. So let's go back to the exercise notebook. And we'll go through this step by step together. So here's the Python. I played it safe. I'm just using a Unicode traitlet. Sorry, Sylvan. So here I've defined value as Unicode and then a hexadecimal color code here. So this is how the web browser defines colors. This is your typical red, green, blue color. And I made sure to put sync equals true. The reason why I named my color value instead of color is because a pattern exists in the widgets in that we call the primary value of whatever the widget is representing value. And so the higher level method of interact can work with value. So if you name your primary trait value, interact will be able to work with your custom widget. I know we haven't covered interact, but in the widget tutorial that I gave last year, you can find the video, the SciPy video of it online, and we cover a lot of interact in that tutorial. So moving on to step 2, defining a render method that creates the color picker. So here's the same code that I showed you guys to give you a little hint partway through. So here's the render method. Create the color picker using jQuery and set the type to color, and then append it to this.L. So that will get the color picker on the page, but it will be a useless color picker. Next step, hooking the event up to listen to the model. So this is very similar to what we saw earlier with the example widget code. You use this.listen to listen to the widget model, change event of value. So this funky change value syntax is a backbone JS thing. And then we specify our listener. So this update value function that we defined below, and then the context that we want this to be called in. And then we also call that same value initially, so the value gets the initial color that we've set as the default in the back end. So the Python value that I've set of 990000 is like a brick red color. And so in order for the color picker to have that by the time we display it, I have to make sure that I set the value right to the initial model push that I get from the back end. And then the last step, which some of you may have gotten stuck on, is listening to when the color picker changes and setting the value of the model. So here I do this.colorpicker.on, and because color picker was created with jQuery, this is a jQuery function, right? Because this is a jQuery handle. See above, we created it using jQuery, so this is a jQuery handle. So this.on is actually jQuery's on, and we listen to the change event and tell it to call our setValue method to update the value trait of our model using this.colorpicker.val, and then we do this.touch. So going back a couple steps, there's this funky this.bind. This is very similar to what Matthias showed you earlier, where this you could alternatively write this as jQuery.proxy and this.setValue this to make sure that the context is correct. This is they do the same thing, but doing .bind is a neat way of avoiding using jQuery. Not that it buys you anything, but it's just a different way to do it. And I want it to kind of demonstrate that there are multiple ways to do that. Coming back down to here, once again, color picker is a jQuery element, and so .val is actually a jQuery function. So you would have to refer to jQuery docs to see how to use that. So now let's go ahead and give this a test. I included some lines below to display the widget twice so we can make sure that it's staying synchronized. I'm going to go ahead and run this final solution and scroll up and run the Python solution. Let's scroll back down, instantiate it and display it. There we go, it's displayed on the page. Let's display another, cool. They're both default to brick red like we want it. If I change one, you can see that the other is actually changing in real time as I'm changing the color. This is a Chrome thing. Firefox actually fires the event after you close the window. So if you're using Firefox, you won't see this real-time stuff. Instead, once you close the window, then they will become synchronized. That's just a difference in the way that Chrome and Firefox implement this color picker element. Next, we can see what the color is. So that's not that brick red that I said earlier, so that's good. We can access it from Python. And we can update the value from Python, so here's a lime green. Any questions with this example? Either clear enough or really confusing? Okay, clear enough? Yeah. Clear from the front row. What about the back row? So the code I have doesn't work. What I would do is sell all output clear, and then file, save. This is a lot of steps, I know. Refresh page. And then go back down to the code that I have, run the JavaScript first, and then the Python. Actually, you could run the Python or the JavaScript in either order. I'm just being a little superstitious. And then it should work. It's worse now? Okay. I will see you in a couple seconds. Or Thomas can see you. So continuing, let's go back to the widget low-level notebook. I have way too many tabs open, so close all to the right. Okay. So briefly, I want to talk about packaging. I'm really running short on time, so I'll make this quick. Installation and distribution of widgets is a really annoying problem because you have both this code that this JavaScript code that eventually shows up in the front end. So the web server must know about it in order to get it to the front end. And then you also have this code that needs to live in the kernel. So you need to install things in 2 different places. The harder of the two, for Python's case, the harder of the two is getting the static assets, the JavaScript, to the page. Because with the Python code, we can just use pip, right, to distribute our package. But for the JavaScript stuff, we have to resort to some trickery. There are a couple different ways that you can get JavaScript to the page in the notebook as is. You can use custom.js, which is a profile-specific thing. That's a JavaScript file that gets ran when any notebook page loads. So you can put any code you want in there that's JavaScript, and it will get executed right when the page loads. You can also put files in the same directory as that custom.js, and it will be available relative to the custom.js. So you'll be able to do relative imports. You don't want to distribute your widgets like that, because then you have to tell your users, hey, here's this Python thing you install. Oh, wait, also I need you to go and edit your custom.js, add this line here, drop these files into this folder. So it gets kind of messy. You don't want your user to have to do that. Another way to get static things onto the page is server extensions. And Matthias mentioned this earlier in the talk, but this is not really a way you want to go, because then you have to worry about security, because this is something that lives on the server, and if you don't write your API handler correctly, there's a potential for people to inject stuff. And so if you're not a security expert, you might not want to use server extensions. And also with server extensions, you still need a way to get the notebook to run the code. It will just make the code available as a static asset somewhere by some HTTP handle, some URL, but it won't actually run the code if you need something to be ran. In the case of widgets, we're lucky, and we actually don't need something to be ran for most cases, because it gets ran when the user runs Python. So it can be deferred until the user actually imports the widget and displays it or instantiates it. The last solution I want to talk about is NB extensions. And that's something that you guys looked at a little bit earlier. Matthias had you copy that file into that folder, and it was available magically. And then you used the front-end config stuff to tell it to automatically load. Well, that same mechanism exists on the web server. There's actually a method called Jupyter, what is it? Thomas, help me out. Jupyter install NB extension. Is that the name of the Jupyter space install NB extension?
Just change the Jupyter NB extension install.
Okay, Jupyter NB extension dash install, right? Okay, Jupyter space NB extension space install. So that command exists in the back end, but there's also an API that exists, so you can call that programmatically. And so what I tend to recommend, and what we've been doing in our own code, is to write a little Python install script alongside your setup.py that gets installed by pip and then is accessible via python-m, your module name dot, then whatever your install script is called, like install. That way, the user can just pip install. This is an example. Pip install your widget, and then python-m your widget.install. So it's 2 steps. That second step, once again, is taking the static assets and putting them inside the NB extension folder, and optionally making those static assets execute on page load. And when you do this type of distribution works with things like Jupyter Hub. Jupyter Hub uses the single user, the single user notebook by default. So the spawner will use the same notebook that you use when you do Jupyter Space Notebook with Jupyter Hub. Yeah.
So is there any way to inject JavaScript in at runtime? Right? If suppose I just do pip install IPyWidgets, could I have the users instead do IPyWidgets.install in this notebook, and then
Yeah.
grab the JavaScript from Python land and stick it in the notebook?
Yeah, totally. So you can do that using the rich display framework. You can create JavaScript. I think it's under ipython.display.javascript. Create a JavaScript instance, and then use that same display method that you did earlier to display that to the page. And so what you would do is create a function that did that, and then they could just call that function, and it would do that
Is
itself.
there any reason we can't just do that at import time?
That's what the widgets does. But sometimes, for things other than the widgets, you need something that runs at page load to hook like events. So for everything that we've done here so far, you don't need that. But like what Matthias did earlier with you guys, where you did that front end config and it got the hello world or hello SciPy to print, that is an example of something that needed to run at page load, right?
Was there particular thinking ahead on or some reason for the choice of not running install in the setup.py? Are you thinking about
So-
different users or?
So I actually wrote something that does that. It's called Jupyter pip. There's a problem with that in that you can't make wheels if you do that. And
The server can be on a different machine than the kernel.
yeah,
Right, that's what I figured your reason.
and that too. And yeah, there's a couple problems with that. But it is a very dreamy thing to think about, like just one line. Like that's what I've been thinking a lot about lately. This is a big problem that we have that we need to solve. Is making this a single line install experience.
Yeah, I was gonna say, the question you had there, what I've been doing, and I don't know if that's my way, but I have several objects that use the rich display, and each one of those that gets output does the required JS of the modules and wraps that around my outputs. And so that, I mean, it seems like a waste because I have to do that for every single object that gets rendered, but it's a way to do it that, my users don't have to install all the JavaScript.
No, yeah, that's the perfect way to do that. That's the right way to do that.
The only
But
problem is that then all my JavaScripts have to be on some CDN or something that everybody can access without having to install.
oh, yeah, I guess I see what you're saying. I mean, you still need to get the JavaScript into a folder. You could use entry points or something of pip to make it accessible, and then use the rich display framework to display it. So you could do that without needing a CDN, but still that doesn't solve the problem of configuring things to load when the page loads, which is a necessity, not in the case that we're talking about, but
Yeah, mine just basically reconfigures it every time an object that comes back to the display, it just asks for everything all over.
yeah.
It's a little bit messy because you have to actually look to, if you import CSS, you have to make sure you don't keep adding those in there with a required.
Require should cache it.
Does it
We can try to discuss that at the sprint if you want. You can sit
Yeah.
down and see what are your requirements. And basically, maybe there is something we need to change.
Yeah, we do have a big list that we're maintaining of things that, when we solve this problem, things that we want solved. So any specific use cases is always a plus for us. So either after, if you're not for the sprints, after the conference, let us know. Or after this tutorial. So yeah, segue into Jupyter Hub. This kind of stuff that you saw will work with Jupyter Hub as is. Thomas, do you want to come talk about Jupyter Hub? Anyways, I hope you guys like the widget stuff. And I'll leave you with Thomas.
Okay, so it's going to really be a shifting of gears for the last 20 minutes now of the tutorial. So we're going to be talking about Jupyter Hub, which is a solution for managing multiple users on a Jupyter system. If my screen can deal with the fact that it's just got a lot smaller. There we go. So we've kind of got two systems for managing multiple independent notebook servers for multiple users. Jupyter Hub is when you want people to be, when you want people to be authenticated with a whitelist of people that you control and relatively permanent resources, like if you're administering a class or something. The other one is TempNB, which is much more for sort of like public online demos where anyone can connect to it and they don't have to log in, and it just starts them up as a notebook server. And typically that's a transient thing that sort of discards the servers when people haven't been using them for a few minutes. So Jupyter Hub is the one we're going to be talking about. And I'm not the expert on it in the room, so Min, sitting in the back, actually wrote Jupyter Hub, and both John and Jess have done substantial deployments of Jupyter Hub for classes at San Luis Obispo and Berkeley, respectively. So this is, although it's a relatively new project, it's already something that people are using in sort of serious production settings, and I think it's worked very nicely. Yeah. So it's like really the use case when it was designed is for this sort of this case where you have like a class of students or a work group of people working together. So you have kind of semi-trusted users, and you want to have them logging in through a web interface and getting independent access to notebooks, which they can edit and run. So this diagram kind of illustrates the basic idea is that, Matthias, me, and John could all log in through this, and we would get our independent notebook servers running on some sort of central server, which we could run notebooks on. So I'm strapped for time. I am going to go through this and try to get a Jupyter Hub system up and running on my own machine, just as a demonstration. You're welcome to try and follow along. All the instructions are in here. But we were planning to have rather more time to do this, so I apologize in advance if I'm going quite fast. So there are three main pieces to Jupyter Hub. So the bit we call the hub itself is the sort of coordination piece that manages the authentication. There's a bit that sits in front of this, which is a configurable HTTP proxy, configurable in the sense that like its proxy routing table can be updated while it's running. So you can add different backends to it without stopping and restarting it, which is important for our use case. So that like the authentication and control hub is sitting behind this proxy. So HTTP requests coming in that go to the hub path are routed to the hub, unsurprisingly. But the hub is also controlling the proxy. So as new users log in, it will add entries to the proxy's routing table to route those users to their own servers. And then the third part are the users' individual servers. And like all of these can be on different machines if necessary. So you could have one proxy machine sitting in front of a notebook, a machine running the hub, and any number of machines could be running in parallel different users' notebook servers. Or, as I'm going to demonstrate on my own laptop, all of these pieces can be running on the same computer. So they're all things that just communicate over network services. So the one thing that complicates installation a bit is that the configurable HTTP proxy is written in JavaScript rather than in Python. So it's not browser JavaScript, it's Node.js JavaScript. This is just, if you haven't come across Node.js, this is an interpreter that runs JavaScript programs, just like CPython runs Python programs, and there's an interpreter that runs Ruby programs and whatever. Node.js is just an interpreter for JavaScript programs, and it doesn't involve a browser at all. And the package manager that goes with Node is inventively called npm for Node Package Manager. And the other package, well, one of the other package managers for JavaScript, not just these two, unfortunately, is Bower. So npm is for JavaScript on the server side. Bower is for JavaScript on the JavaScript modules that will be used on the browser side. It's used internally in the installation, but you won't actually see that being called in these instructions. So Node itself and npm are dependencies for this. You can install Node with npm from Node's website, nodejs.org. On Ubuntu, you can also, or Debian, you can also install these packages, npm and Node.js Legacy. So Node.js Legacy just makes Node the Node executable, because there's an older executable on Debian systems that's also called Node. So they got upset at the fact that there was this JavaScript thing called Node as well. So I've already done that step, so because we're short of time, I won't demonstrate it. And then you use npm install -g. So normally when you npm install, it kind of installs inside the project that you're currently looking at, inside the current working directory. In this case, that's not what we want, so the -g flag means install globally. In this case, my system seems to be set up, so I don't need the sudo command for this. Your system might need it. So that's been installed, and now configurable HTTP proxy is a command that I can run there. If I just run it by itself, it's not going to do anything useful, but it's on my system now. So next up, I want to get the code for Jupyter Hub itself. So I've just cloned the repository, and now I'll cd Jupyter Hub. Now I'll cd into that, and I'm going to run Python 3. This is probably small, isn't it? .py, JS, and CSS. So this is just going to go and grab the other JavaScript dependencies. I think mostly Bower things, front-end packages that this needs, and build its CSS. So that will take a couple of seconds. We can leave that churning away. Then in a moment I'm going to install the Python dependencies. How are we doing for time? 10 minutes, okay. Race against the clock. So there's all my JavaScript stuff getting installed. And it says it's built the CSS as well. So now I can say I want to install the requirements, and before I plugged my laptop in, I've created, in this case, a Conda environment to install things into. You can do it with a virtual env, or you can install these things globally. At this point, now that we've done the JavaScript steps, now we're just doing standard Python packaging operations, and it's saying all of those are already found because I've got them installed in my home directory. And we can do pip3 install dot. So this is now installing the Jupyter Hub code itself. So that's Jupyter Hub installed, and if I run the command Jupyter Hub, it should now, if all goes well, it says Jupyter Hub is now running at localhost 8000. So this is kind of like the authentication part of the Jupyter Hub interface by default. So when I've just set it up with all the default settings, it's using the authentication system on my local computer. So what I use here is the same username and password that I use to log into my computer. And there we go. So it's logged me in, And this has now started my individual notebook server, and you can see you may not be able to see very well because it's tiny, but up at the top here, the address is, oh, I've got the wrong notebook here. The address is now, instead of the usual URL when you start the notebook, it now has user TA Clover in it. So this is my notebook server that that Jupyter Hub has started for me. And I think I'm going to, so I'm not going to try to demonstrate the next bit because it's a bit long-winded, but the important takeaway from the next 2 bits is that there are two major interfaces where you can plug in other pieces to Jupyter Hub. So with these are called authenticators and spawners. So authenticators are how it authenticates a user, how it decides that I am user TA Clover, and how it verifies that I'm really who I claim to be. So there's a couple of different ways that you can provide this. The simplest one is that you can just give it something that takes a username and password. It will present this little login box, and you can, the module you provide can get the username and password and just return a value to say whether or not that's valid. You can also provide something like an OAuth interface. So the example in this notebook uses GitHub OAuth. So you set up a GitHub application and install this module and configure Jupyter Hub to use that. And then when you go to Jupyter Hub, there'll just be a button saying like log in with GitHub, and you click that, it will redirect you to GitHub and say like, do you give Jupyter Hub permission to access your GitHub basic user information? And if you say yes, then it will redirect you back and you'll be logged in. So yeah, I think we're probably short enough of time that we won't try to demo it even on Demo Hub. But yeah, there is a site called Demo Hub where we have this working, so you can go to that and see what that experience looks like. The other pluggable interface is the spawners. So the default when I do it on my laptop is that it just creates the single user servers for me as a sub-process. So it's just running with no isolation or anything. But you can, anything that will start up a server and provide like an HTTP address to talk to that server, you can use as a spawner interface. So a very popular one, and like the one that Jess used for the course, is a Docker spawner. So it creates a Docker instance for each user who logs in and starts the server in that. So you have some kind of like constraint on what they can do there. And the notebook also has, this notebook also has instructions on how you would set up the Docker spawner. And that works together nicely with the GitHub authenticator, because if you just set up the GitHub authenticator, then it will only work if your GitHub username exactly matches your local username, because it's using that local username to run processes on your computer. But if you set up this Docker spawner, then it's independent of your system usernames. So that was the whistle-stop tour of Jupyter Hub. Feel free to ask questions. We're going to put out on these two tables at the front pads of paper that we've divided into columns with plus and minus. If there's any feedback you've got for us,
please come and write it down on these pads of paper, and we won't look at who's writing what until you've all gone. So it's kind of like simple anonymization. Thank you very much, and yeah, we're happy to take questions.